period. So we are on lesson 1.5. We did our test on 1.1 to 1.4, and now we're on 1.5. We have 1.5, 1.6, 1.7, and then we're up for another test. I do want to give a disclaimer because the next 2 weeks are wild. Next week, we have retreat and PSAT on Wednesday. And then the week after is fall break. And we have Mission Monday, Tuesday is e-learning, and then Wednesday, Thursday, Friday, we're all off. So the next 2 weeks are wild. We will probably finish this stuff, and we will probably have to start learning chapter 2 before I test you. I'm just giving you a heads up that that's probably going to happen, okay? So know that we may finish this, and I may be like, all right, now we're starting 2.1, even though we haven't tested, because I want to wait till we're back in person, okay? Just be a really weird next couple weeks. Just deal with me, okay? All right, so we are in 1.5, and we are talking about, well, actually, does anyone know? What is this symbol right here? F to the negative 1, what does that mean? Awesome, great. None of us know, which is great. Helps me know what's going on with you guys. It means we're doing the inverse of a function. F raised to the negative first is the inverse of f of x. When we do inverses, we are switching our x and y's. Switching your x and y's. If I give you points, we switch our x and y's. If I give you a graph, we switch your x and y's. If I give you an equation, we switch our x's and y's. I hope everybody's with me. Okay, what I'm going to do now is I've got a few algebraic equations. We're going to solve for what the inverse function is. F of x equals x plus 2. I'm going to switch my x and y's, but I don't even see y here. Where's my y at? The f of x. That is the same thing as y. So if I want to switch them and write my inverse, I'm going to write x equals y plus 2. Once we switch, now we need to solve for y. And once we find y, then I will have found my inverse function. So x equals y plus 2 minus 2 from both sides. And I get x minus 2 equals y. This is a good enough answer, but I want to write it in correct notation, at least for a little bit at the beginning, so we get comfortable with it. So correct notation of this would be f to the negative first of x equals x minus 2. That is my inverse function of this guy over here. Any questions on that? Oh, let's do another one. Same idea for the next one. F of x equals 3x plus 1. Replace my y with x and replace my x with y. We've got x equals 3y plus 1 minus 1 from both sides. I don't normally show the like minusing and dividing and adding, but sometimes, especially with inverse functions, I can miss a negative or move something over and it's positive when it shouldn't be. So I'm really, really careful about how I move it. In order to get rid of the 3, you divide both sides by 3. And so that gives me x minus 1 over 3. And put a y in equals in front. You also can split that into fractions. You can write 1/3 x minus 1/3. That's okay. I personally would rather leave it in like the big fraction like this. I think that's just as simple and it means the exact same thing. So, however, a benefit would be if I'm graphing a line is to write it like this because I have a slope and a y-intercept really easily identified. All right, let me write it in correct notation. F to the negative first of x equals x minus 1 over 3. You doing okay? Can I keep going? All right. The next one, I think this is one of the harder ones. So go to the next page. I've got a fraction with x on top and on bottom. It's the exact same process. It's just the algebra to it can be a little bit more confusing. So let's be careful as we do this. So I'm going to say x equals 2y minus 3 over 5y plus 1. In order to start solving, I want to get rid of the denominator. I never want a denominator any longer than I need it. So I'm going to multiply by 5y plus 1 on both sides. It cancels on the right side to give me just 2y minus 3. And then the left side is a like distributive problem. X times 5y plus 1 equals 2y minus 3. I do want us to distribute that x. And the reason is I need to distribute that x because I need to get the y together at some point. And I can't get the y together unless I am able to like minus or add or something to the other side. So we're going to distribute, and it's going to get a little uglier before it gets prettier. And that can just be a life lesson. Sometimes things get uglier before they get prettier. Now I want my y's together, and I want everything that's not a y together. So I need to get 5xy and 2y on the same side of the equation. They cannot be combined, but they can go to the same side of the equation. And then I want the x and the 3 to be on the same side as well. Anyone have a preference on where we move things? Nope. You can move things either way. I'm probably going to do this. I'm going to minus x from both sides, and I'm going to minus 2y from both sides. You could have moved the other things. I could have moved the 3 and the 5xy, but it doesn't matter. So I've got 5xy. Whoa. Nope. Okay. Minus 2y equals negative x minus 3. We're almost there. In order to get my y by itself, you can factor it out of both of those terms. I got a y in both, so I can take it out. Y, and what's left if I factor a y out of the left side? 5x minus 2. And last, we want to get y all by itself, so let's divide by 5x minus 2. Y equals negative 3, y equals negative x minus 3 over 5x minus 2. And correct notation would be f to the negative first of x equals all this crazy fraction stuff. Okay, I guarantee on the next quiz or test we take, there'll be a problem like that. So I would star that, I'd highlight it, I would know how to do a problem like that. I don't think it's the hardest thing you've ever done, but it is hardest of these types of problems. So really make sure that you know how to do this. Any questions on that one? Letter C? Okay, let's look at letter D. Switch your x and your y. X equals y minus 4 under the radical. How do we get rid of a square root? Square. X squared equals y minus 4. And then what's my last step? Add 4. All right, we just did 4 examples. To find the inverses algebraically, you switch your x and your y's, and then you solve for y. Great job. Next, I have one example before we talk about a new concept. Now it's points. How do I rewrite that to find its inverse? No, I don't even need to find an equation. Just flip the x and the y. If it gave me a set of points, I'm going to give it back a set of points. Switch the x and the y, and that's my new answer. So instead of 1, 2, it's 2, 1. Instead of 3, 4, it's 4, 3. Instead of 5, 6, it's 6, 5. And instead of 7, 2, it's 2, 7. All right. Okay, the next concept is something called one-to-one. I had to remind you of two things first. First, if I write VLT, do you know what that means? Vertical line test. And what is a vertical line test? Good. A vertical line test is a test we use on a graph in order to tell if it's a function or not. So it tells us if a graph is a function. I'm using FUNC to represent function today. I just don't feel like writing it all out. So the vertical line tests are vertical lines that tell us if the function is a function, if the graph is a function. Now, do you remember something called the HLT? The horizontal line test. That tells us if the graph's inverse is a function. That says, okay, well, if we were to do a horizontal line, then that would mean that the graph that you're looking at, that its inverse is a function. The new concept is something called one-to-one, and that means it passes both tests. Both the graph is a function and its inverse is a function. It passes both the vertical line test and the horizontal line test. So one-to-one means both the graph and its inverse are functions. And it means it passes both VLT and HLT. So I'm just looking at the next four graphs. I'm just drawing some lines. All right, is that first graph one-to-one? Does it pass the vertical line test? Yes, it does pass the vertical line test, okay? Does it pass the horizontal line test? No. So since it does not pass the horizontal line test, it is not one-to-one. Bless you. Someone sneezed. Not one-to-one. And you can write a little note to yourself. I'd say the VLT is good. I'd give it a check mark, and I'd say the HLT is bad. That's just a note. So if I go home and I'm like, why did I write no next to this graph? I know exactly why. Oh, all right. Oh, I'm sorry, I'm so yawny today. What about letter B? Nope, not one-to-one. What does it not pass? It does not pass the vertical line test. So its VLT is bad, and it actually does pass the HLT, so we'll give that a check. But again, it needs to pass both, can't just pass one. What about letter C? Yes, that one works. Both of them pass. And then what about letter D? Yes. All right, questions so far? Okay, next I have a part that says prove the following pairs are inverses. Okay, let's first talk about something. I'm gonna write a little note off to the side. If two functions are inverse, oh, okay, now you don't wanna work? If two functions are inverses, then their composition, remember composition was the last lesson we learned where we did f of g and we did g of f. Those will equal x. So if I have two functions that are inverses of each other, you do the composition, both directions, f of g and g of f, and it will equal x. Let's see what that looks like in practice, okay? Essentially what you can think about, if it says prove that they are inverses, we're gonna do the compositions and see if they equal X. A little word from the wise is if it says prove, it means that it's true. If it says prove that they are, then I would say, okay, they must be inverses. Let me just show that they are. If it says, are they inverses? We don't know. It could be yes, it could be no. So this isn't a question. It's just like, show me that they are inverses. So they should both work. That's kind of what I'm getting at. All right, so I've got f of x and g of x. I need to do f of g of x. So I'm going to put g into f at x. So I look like 3 parentheses plus 2. And instead of writing x, I'm going to write all of g in that parentheses. X minus 2 over 3. Before I solve, let's set the other one up. Let's do g of f. Now I'm going to put f into g. So I'm going to put 3x plus 2 into g at x. So it'll be 3x plus 2 minus 2 over 3. Now I put parentheses there. They technically aren't doing anything, but I'm just proving a point. Does anyone have questions on the setup? All right, I'm going to go back and solve. So we're going to simplify, and we want it to equal x. So I'm going back to f of g. I've got 3 times x minus 2 over 3 plus 2. The 3's are going to cancel. 3 times something and then divided by 3 cancels out. So I get x minus 2 plus 2. Negative 2 plus 2 is 0. Oh, nice. I just got x. Nice little surprise. You got a little happy face there. Happy about it. Cool, that wasn't too bad. Let's look at the other one. Make sure it also equals x. Okay, so I've got 3x plus 2 minus 2. I just told you the parentheses don't really matter. So if we want to rewrite the next step where it's just 3x plus 2 minus 2 over 3. We got to start with what's in the numerator. I do have a positive and a negative 2 though, so those cancel out. So I get 3x over 3. Ooh, and the 3's cancel out and I get x. Yes, that's exactly what I wanted. Another little smiley face. When they both work, then I would say, yes, these are inverses. So like these are, yes, they are inverses. That's true. You just would show the work. All right, let's do the next one. Can you set that one up? Are you all done? Yeah, thank you. Oh wait, Megan, I didn't tell you to do the bonus. Do you want to do the bonus? Yeah. You can just do it anywhere there's a blank spot. Label it bonus. All right, pause, make sure your setup's good. Is that what your setup looks like? Awesome. All right, start simplifying. I get the 2's to cancel, so I get 5x plus 7 minus 7 over 5. My 7's cancel, so I get 5x over 5. And my 5's cancel, I'm left with x. Nice. Next one, same idea. The 5s cancel, so I get 2x plus 7 minus 7 over 2. My 7s cancel out again. I get 2x over 2. And then my 2's cancel out, and I'm left with just x. Nice, another smiley face. Perfect, very good. All right, any questions on the inverse part of this? Okay, we're gonna move into a new section of 1.5 called the parametric equations. So I need your calculator for this one. So make sure you have your calculator with you and turn your page, and we're doing what we call the parametric equations. Thank you. Becca, did I need to email your person? Yeah. Who is it?
Mr. Shine.
Okay.
Thank you so much.
Thank you. Let me do that really quick. Hope that's not on the recording. Can I make that big? I just don't need my email on the whole screen. I don't think I have any secrets, but if you ordered a junior class shirt, though, go pick it up. That's the first email I see. All right. Move your calculators. Where's my notes? Oh, here are my notes. There's my Zoom. Okay. Okay. Sorry. Thank you for them letting me interrupt for 1 second. We're on our parametric equations. Oh, that was close. All right. Okay, parametric equations are a new type of equation. Essentially, it is 2 equations in terms of t. You will have one equation that says x equals something with a t, and you will have something y equals something with a t. They're called parametric equations because your t is the parameter. The parameter is a certain value that we plug into both equations, and we get out the corresponding x and the corresponding y. We're never graphing our t's, but we're using the t's in order to find our x and y. I'm going to write t equals the parameter over here. And we're going to solve. I do not think this is something you've ever seen. So it's not difficult. So let's just take it piece by piece. The first one says, find the points determined by t equals -3, -2, ... 2, 3. That means I need to find out x and y when t is -3, -2, -1, 0, 1, 2, 3. So we're going to make a little chart down here. I'm going to have t, I'm going to have x, and I have y, and they're going to be little columns. Or I guess rows. I guess these are rows because they're sideways. So I've got rows, and I'm going to label all my t's as -3 to +3. So all of these should be labeled. Once we do this, we're basically just going to plug and chug to find my values. Why would it give me this? It always gives me curvy lines. It makes me so mad. I don't know if anyone else feels as strongly as I do, but the curvy lines on notability is pointless. Okay. All right. We have all of our t's. Now let's find our x's. We want to use the equation that was given above to find all my x's. So I'm going to take every t and do that number plus 1. If you don't remember it, I'd write them off to the side over here. It'd be like x equals t plus 1, and I'm going to plug t in for all my values. -3 plus 1 is -2, -2 plus 1 is -1, 0, 1, etc., etc. Everybody with me? Say again? Now, x and y are independent of each other because they're in terms of t. So when you go do y now, don't plug your x's in, plug your t in. So I'm going to go do t squared plus 2t. My biggest piece of advice is don't be too cool for school. If you can't keep it straight in your head, write it out. So I'm thinking about it as each t squared plus 2 times that number. So like my first one's -3. Well, -3 squared is 9. And then 2 times -3 is -6. So 9 minus 6 is 3. And I'm essentially just doing that all in my head now. Everybody listening? We are a quiet group today. Half of us are asleep. Either with your eyes closed or with them open, I can tell. 4 minus 4 is 0. 1 minus 2 is -1. 0, well 0, yep, that's all zeros. 1 plus 2 is 3. 4 plus 4 is 8. And then 9 plus 6 is 15. Any more questions on how I got my x's or my y's? So now I've got a t-table. I could literally just plot all those xy points. But instead, I want to find an algebra equation that represents how x and y are related to each other. And it says we are doing that by eliminating the parameter. That is for sure words I use on assessments is eliminate the parameter. What that means is the parameter is t. So if my parameter is t, that's going to get really old really quick. If the parameter is t, we just don't want it in my equation. So if I can rewrite x or y in terms of t, then I can plug that in and then solve. So it looks like I have x equals t plus 1 and y equals t squared plus 2t. Which of those looks easier to get a t by itself? Yep, x. So the x, because it says y equals t plus 1. So if I set that, if I solve that to get t by itself, you just minus 1. That's super simple. And I get x minus 1 equals t. Now, since I solved for t, I'm going to plug x minus 1 in for t into my y equation. I'm substituting it in. So I've got y equals t squared plus 2t. Well, I'm going to take out the t's and write my x minus 1 squared instead, and 2 times my x minus 1 instead. You okay with that? The biggest mistake now we make is when we don't FOIL right. So make sure when you FOIL, you're multiplying x minus 1 times x minus 1. Make sure you get a middle term. So I've got x squared minus 2x plus 1 plus 2x minus 2. And then I simplify. Well, my 2x's cancel, okay. And I get x squared minus 1. Okay, questions so far? Yeah, it just says find the algebraic relationship, which is just an equation. Now everything's in terms of x and y, and that looks familiar to us, right? Y equals x squared minus 1. Then it says sketch it by hand. Oh, we can do that. We can sketch that graph. What's that going to look like? A parabola? And what's its translation? How did it move? Down 1. Why is it down 1, Ellie? Good. The minus 1 is outside of the square, so it moves it down 1. And then I just parabola from here. Whatever, it doesn't have to be exact. That looks pretty good. You can also check your work because your points should be the same, right? I have a point right here at 0, -1, and I have a point right here at 0, -1. It looks like I crossed my x-axis at positive and -1, which is exactly what my graph does. You don't have to graph the exact points, but you can if you want to. All right, now it's time for the calculator, so get your calculator out. Everybody wait. Everybody with me. I'm losing you. I know this has been the longest week of my life too, and I'm so tired, but we all gotta stick with it. This is also, I think, one of the easiest chapters we're gonna do. So if we can just focus up, this will be a great test eventually. It's not a lot of information. Okay, let me move over to my calculator so we can see it. That is not shared with Zoom, is it? I have no idea what my Zoom screen is.
On the Zoom? Oh,
Yeah,
never
what
mind.
do you see on the Zoom, Janae?
The calculator.
Oh, perfect. Okay, great. Normally it has like this big like green box around what I can see, but I don't see it on my screen. So, okay, perfect. But if you can see the calculator, that's all I need.
Yeah, and then before that, we were seeing the notes.
Awesome. Okay, so everything's been good so far?
Yep.
Awesome, thank you. Okay,
You're welcome.
we are gonna do calculator stuff now. And I don't think you've ever done this. So this is parametric equations. What I want you to do is press the mode button. You press mode, do you see mine's like 1, 2, 3, 4 buttons down. It says function, parametric, polar, and sequence. Some calculators, it just says P-A-R-A, but that means parametric. So we're gonna click on that. We're gonna press enter. Now it's like highlighted. And now I'm gonna get out of my mode screen. So I'm gonna say second mode, which quits me out. And now I'm just on a normal screen. Right now, it looks like nothing has changed. I want you to go to your y equals. Now it says x equals and y equals. If we're in the parametric mode, as we just learned, parametric equations are in the terms of x equals something with a t and y equals something with a t. So that's what we're going to plug in. We're going to plug in what we need to do. We're doing x is t plus 1, right? Now you may ask, where's t at? Well, where's our x at? We normally type in x. If you click on x now, it doesn't say x anymore. It says t. It changes based on what mode we are in. So since we're in the second mode, it's giving us the second variable, which is t for parametric. I'm write t plus 1, and then I'm going to write down t squared plus 2t. And then I'm going to press a graph. Oh, beautiful. Oh, you only got half of it. Okay, this is what happened. Let's go to Windows. Where are you at, May? Where can I pick you up? We're typing in the parametric ones. So, yep, the ones given to us. Okay, so go to Windows. If you only got half a graph, what happened is your T min and your T max are not correct. At least on my graph, I had 0 and then like 6 for my T min and max. Is that what you have? Yeah. I think it gave you like 2 pi. That's what 2 pi is in decimal form. What we want is we didn't plug in 0 for t, right? What numbers did we plug in for t? If you remember back, here, let me see if I can pull our notes out. We plugged in -3, -2, -1, 0, 1, 2, and 3. So if we don't have at least -3 on our graph, then we need to make sure that like that's part of our window. So go back here. And so I made my window -5 to 5. So that should get at least our -3 to +3. Probably not. If you want to make sure that you don't have to fix it again, I'd probably go to like -10 or like -100 and make sure that you never have to fix it again. So mine from last year, for some reason, had been set at negative like 150 and positive 150. So I don't know what we did last year, but I must have done a problem that like we needed a really high T. So like I had it here and it was, there's no problem. If you just like clear, oh, you reset the whole thing? Oh, really? You might have to fix it every time then. Mm-hmm. Yep. That's so interesting. I've never had a teacher tell me that. So I've never. And so it was just like, just always reset. Okay, that makes sense. Yes, so then if that's the case, you're gonna have to always reset it. But if you at least have -5 to +5 or -3 to -3, you should be able to now get a pretty two-sided graph. Does your graph now look like mine? Awesome. Okay, that's what it was. So if you're looking at a parametric and you're like, it doesn't give me a full graph, see if you can fix your mins and maxes for the t's. All right, so now it says, D says sketch that original equation on the calculator. So we went through the steps on the calculator. It's the exact same as what we just graphed by hand. So you can write the same or you can draw the graph again, whatever floats your boat. You can write same, or I can just do it again really quick. It's not that much skin off my back, something like that. Just a sketch. All right, let's do the exact same thing for the next problem. So I've got x equals 2t and then y equals 3t minus 1. The same like steps. I'm doing both. I'm doing everything. So basically, I'm like, these are all the things I could ask you to do. I will not always ask you to do those 4 things. Probably not. Yeah, I might not even make you sketch on the calculator, but I might give you a problem where like it's helpful if you know how to do it on the calculator. So that's why we're going over it. All right, so let's do the next one. So if we start by doing our letter A was finding the points. So make sure you have a table set up. Let's start doing our table. Once I set my table, I'm gonna start plugging in points. The biggest problem I've had on this is I've tried to plug my X in for my Y. And remember, you're always using T. So if you end up getting a wrong problem, it's probably because you use X instead of T. Any questions so far? All right, can someone help me with B? What do I do to find the algebraic equation with X and Y? How do I eliminate the parameter? Find T? Good, which one are you gonna find T from? X or Y? Perfect. X equals what was it, 2 times T? Good, get X by itself, divide by 2. X over 2 equals T. And then I'm gonna plug that into Y. That's not bright enough. Y equals 3 times X minus 1. And instead of writing, or sorry, T, 3 times T minus 1, instead of doing that, I'm gonna plug in X over 2. Now my last class got here and then they were like, I don't know. In this case, I have 3 times X divided by 2. None of those pieces can simplify, right? So we can write it in what makes the most sense to us. I would write it as 3 halves X minus 1. Essentially, this is like 3 times X times 1 half. And so you can move it all around to whatever you want. It's commutative property. You can make it look how you want it to look. I think since this is a, what kind of function is this going to be? A what? Linear function. So it's a line. If it's a line, then that means my slope and my y-intercept, I want them to be super easily noticeable and recognizable. So graph number C says graph that. So let me rewrite y equals 3 over 2 x minus 1. And graph it. So -1 and then up 3 over 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Something like this. Questions so far on A, B, or C? Now, I know that we're about to get the exact same graph that we just got, but I would like us to practice plugging it in and making sure you know how to find it. So I'm going to go back to my calculator, and I'm going to plug in my new x1, y1, which is 2t and then 3t minus 1. 2t, 3t minus 1. All right, I'm going to graph it. Perfect, just confirming. You can write the same, you can do a check mark, whatever. It's your notes, I don't care what you write. It's checking to see, the reason we're doing D is so that we're practicing plugging into the calculator. I wouldn't ask you to do both of these things, it's redundant. But I want you to practice knowing how to plug it in. All right, we got 2 more problems. Do we have time for 2 more problems? We're gonna do as much of the next 2 problems as we can. All right, this says sketch the inverse of, and then it gives us functions. We just spent a long time doing inverse, and what did we do with inverse? What were we doing with inverse? Flip the x and the y. So we're gonna go to these graphs and flip all your x's and y's. So if my original point was here at 2, 0, I'm gonna flip it, so now it's at 0, 2. Oh, sorry, it's at -2, 0, my fault. My fault. -2, 0, so now I'm gonna graph it at 0, -2, which is here. I'm gonna flip all of these points. Maybe I should use different colors so it's not as confusing. You don't have to label your points unless it's helpful, but I find it helpful. The next one is at -1, +1. So if I flip it, it goes to +1, -1, which is here. The next point is at 0, 0. Well, when you flip 0, 0, it stays at 0, 0. So this is what my graph is looking like so far. Okay, so I did the first part. Now I'm doing the second part. Next, I go to +1, -1. And so if I flip that, it goes to -1, +1. Oh, we already have points at both of those places. Right here. Then it goes over to +2, -1. So that becomes -2, +2, -1 becomes -1, +2. We just finish this graph. And then the last one's at 3, 0, which goes to 0, 3. So it looks something like that. You could draw a new graph. The second one from the top came from here, the 2, -1. What happens is that if it's an inverse, it flips across the line y equals x. And like May said, you can always draw another graph. It might be helpful to like list the points like in a line over here, like -2, 0, -1, 1, 0, 0. And then flip them all in the next line and then graph those points. Whatever helps you. Okay, I know that we're all so